Welcome to Module 2. In this module, we will be looking at the energy use and efficiency in the building sector as it relates to the United States. More than 76% of all U.S. electricity use and more than 40% of all U.S. energy use and associated greenhouse gases (GHG) emissions are used to provide comfortable, well-lit, residential and commercial buildings, and to provide space conditioning and lighting for industrial buildings. Successfully meeting priority technology goals for performance and cost will make it possible to significantly reduce this energy use by 2030, in spite of forecasted growth in population and business activity. But what could be causing that high consumption? Let us look into some areas that may help us understand the building sector energy use. Let's start by assessing the energy use in residential buildings. Where does a building's energy go? Well, let's look at some numbers. In 2019, the average U.S. household consumed about 11,000 kilowatt-hours (kWh) per year. Residential home end users, namely 1. HVAC systems that include space heating, fans, and space cooling used about 35% of total energy. 2. Lighting used 11%. 3. Water heating used about 18%. 4. While other plug loads used about 36%. Did you know the share of U.S. homes with central air conditioning systems increased from 27% of homes in 1980 to 64% in 2015? Single-family type residential homes have seen a tremendous increase since the start of the century. U.S. Energy Information Administration predicts a 110 million growth in residential homes by 2050. Although the number of single homes are expected to increase, energy consumption is not expected to behave the same. The U.S. Energy Information Administration also predicts a decrease in energy consumption per household in the next 10 years. The typical U.S. household now uses more air conditioning, appliances, and consumer electronics than ever before. However, average annual site energy use per home has declined. The reasons for this decline include 1. Improvements in building insulation and materials. 2. Improved efficiencies of heating and cooling equipment, water heaters, refrigerators, lighting, and appliances. And 3. Population migration to regions with lower heating and thus lower total energy demand. Let us take a look at building energy use in the commercial sector. Commercial buildings include a variety of building types: offices, hospitals, schools, police stations, places of worship, warehouses, hotels, and shopping malls. Energy use in commercial buildings differs from the residential. Different commercial building activities have unique energy needs. In general, the most energy consumption happens in these areas: 1. Lighting. 2. Ventilation. 3. Refrigeration. 4. Space heating and cooling. However, space heating accounts for about 25% of the energy consumption among all end users in commercial buildings. The U.S. Energy Information Administration projects that commercial floor space will grow significantly over the next 30 years in the United States. However, energy use grows at a much slower pace. We assume wider adoption of commercial building sensors and controls over time and other factors, including energy efficiency gains and warmer weather, will all contribute to declines in commercial energy consumption to meet heating, ventilation, and lighting needs. Other commercial energy uses will increase. There's a projection of an 8% decline in the energy intensity of commercial buildings by 2050, a measure of energy consumed per square foot of floor space. The commercial floor space is expected to grow by 33%, and total commercial energy use by 22% between 2020 and 2050. Of all the commercial building types, mercantile and service buildings use the most total energy. Mercantile and service accounts to 15% of total energy consumed by commercial buildings. These include malls and stores, car dealerships, dry cleaners, and gas stations. Other commercial users of energy include offices, schools, healthcare and lodging facilities, etc. Now that we learned about the building's energy use, the next question is, Is there a potential to improve energy efficiency, thus reduce carbon footprint as we cut on energy consumption? Taking practical measures to reduce building energy consumption will lead to 1. Addressed issues relating to national energy use and environmental challenges, and 2. Reduce energy costs to building owners and tenants. By 2030, building energy use could be cut more than 20% using technologies known to be cost-effective today, and by more than 35% if research goals are met. Much higher savings are technically possible. What are some of the measures that we can take to ensure energy efficiency in buildings? Building efficiency can be achieved by improving its performance as a complex system designed to provide occupants with a comfortable, safe, and attractive living and work environment. This requires superior architecture and engineering designs, quality construction practices, and intelligent operation of the structures. Increasingly, operations will include integration with sophisticated electric utility grids. Remember the major areas of energy consumption in buildings: HVAC, water heating, lighting, and plug loads. Each one of them has opportunities for improving the performance of system components. For example, improving the efficiency of lighting devices and improving the way they are controlled as a part of integrated building systems. For example, sensors that adjust light levels for occupancy and daylight. Did you know use of Energy Star technologies would reduce residential energy consumption by 30%? Or that use of Energy Star technologies would reduce commercial energy consumption by 21%. Providing a comfortable and healthy interior environment is one of the core functions of building energy systems and accounts for about 33% of total building energy use. New technologies for heating, cooling, and ventilation not only can achieve large gains in efficiency, but they can improve the way building systems meet occupant needs and preferences by providing greater control, reducing unwanted temperature variations, and improving indoor air quality. Improved sensors, control systems, and control algorithms for optimizing system performance can help reduce on energy consumption. The walls, foundation, roof, and windows of a building couple the exterior environment with the interior environment in complex ways. As mentioned earlier, building efficiency can also be achieved through superior architecture and engineering designs, as well as quality construction practices. 1. The insulating properties of the building envelope and construction quality together control the way the heat and moisture flows into or out of the building. 2. The color of the building envelope and other optical properties govern how solar energy is reflected and how thermal energy or heat is radiated from the building. 3. Windows bring sunlight and the sun's energy into the building. 4. About 50% of the heating load in residential buildings and 60% in commercial buildings results from flows through walls, foundations, and the roof. EUI expresses a building's energy use as a function of its size or other characteristics. Generally, a low EUI signifies good energy performance. However, certain property types will always use more energy than others. For example, an elementary school uses relatively little energy compared to a hospital. For calculation purposes, EUI is expressed as the energy used per gross square foot of building per year, expressed as kBTU per square feet per year. Here is an exercise to help you train your energy analysis skills. Take a minute and solve this problem. A 50,000 square foot school consumes 7.5 million kBTU per year. What is its EUI? Similarly, a 10,000 square foot supermarket consumes 7.5 million kBTU per year. What is its EUI? The 50,000 square foot school has an EUI rating of 150, but the 10,000 square foot supermarket has an EUI rating of 750. In this example, even though they're consuming the same amount of energy, the supermarket is far more energy intensive than the school. What is the energy use intensity, EUI, of your home? How can you improve it based on energy efficiency measures that we looked at? Supported sources. Thank you for watching this course on building energy efficiency.